Okay, the change of base rule. Welcome back. This is Nick Agrion. Let's start with this first. We have b raised to x is equal to y if and only if x is equal to logarithm of y with the base 2, or with the base b, sorry, not 2. X is equal to logarithm of b raised to x with the base b. Remember that. Okay? And if I'm going to apply some of the rule here now, we have x logarithm of b with the base. Let's say we will change the base into a is equal to logarithm of y with the base a. Then we now know we have now x logarithm of b with the base a is equal to logarithm of what is y now is, let's see, b raised to x with the base a. So if we divide both sides of the equation by logarithm of b with the base a, then we have logarithm of b with the base a. Then we have x is always logarithm of b raised to x, or y with the base a, divided by logarithm of b, okay, with the base a. Let's see how we can apply that here. It says find logarithm of 9 with the base 2 by letting logarithm of 9 with the base 2 is equal to x. So if we're going to look at a, then we have 2, we have base logarithm of 9 with the base 2 is equal to 2 raised to x. Then we have, this is now 9 is equal to 2 raised to x. Okay, I hope you understand that. And then for b, changing to base 10. So we have now, if we're going to use now properties of logarithm, we have now logarithm of 9 is equal to logarithm of 2 raised to x with the base 10. Then we have logarithm of 9 is equal to x logarithm of 2. And then if we divide both sides of the equation by logarithm of 2, then we have x is equal to logarithm of 9 divided by logarithm of 2. So if I'm going back to what I said a while ago, that this one I'm going to put here, 2 raised to x is equal to 9, for example. So we have x, this is our b, this is our x, and this is our y. And we said that x is equal to logarithm of y divided by logarithm of b. So this is our b. Let's see. So x logarithm of 2 is equal to logarithm of 9. Now we have the same base c and a and a. But here we have 10. Then we have, if we divide both sides of the equation by 2, then we have x is equal to logarithm of 9 divided by logarithm of 2. This one is our y here, and this one is our b there. This is our y. Okay. Okay. I hope. Okay, let's see. For C. For C, we have 9 is equal to 2x. If I can change, not 2x, sorry, 2 raised to x. Sorry for that. If I can change 2 raised to x is equal to 9, it's easier for us to see. Then if I have to do this, x ln of 2, I hope you understand that, because I'm going to use e as a base. So I am not going to use logarithm of e right now. I'm going to change it to ln directly, and then logarithm ln of 9 sorry, and then divide by 2, ln of 2. Then we have x is equal to ln of 9 divided by ln of 2. Maybe I can show you anyway. See here, I can show you with base e. So we have x logarithm of 2 with the base e is equal to logarithm of 9 with the base e. Divide both sides of the equation by logarithm of 2 with the base e. Logarithm of 2 with the base e. That is 1. Then we have x is equal to logarithm of 9 with the base e divided by logarithm of 2 with the base e. If I'm going back once again to the definition we have done, then we have same base there. We have same base there. This is your y, this is your b. The same base there. You can answer that with the base e, but we don't usually do that. That is ln of 9 divided by ln of 2. Okay, let's take some more. Here, solve for x exactly. Then we have here 8 is 2 raised to 3, and 4 is 2 raised to 2. So if we can do that, we have 2 raised to 3 raised to x minus 5 times 2 raised to 2 raised to x is equal to 0. Then we have 2 raised to 3x minus 5 multiplied by 2 raised to 2x is equal to 0. And we know that we have 2 raised to 2x as a common factor. Then what is left here is 2 raised to x minus 5 is equal to 0. Then we have 2 raised to 2x is equal to 0. That means x is equal to 0. And the other one, we have 2 raised to x minus 5 is equal to 0. Then solving logarithmic equations, we have x logarithm of 2 minus, sorry, I did it too fast. I will add both sides of the equation by 5 first. And then we have 2 raised to x is equal to 5. Now we are ready. X logarithm of 2 is equal to logarithm of 5. Divide both sides of the equation by logarithm of 2, logarithm of 2. Then we have x is equal to logarithm of 5 divided by logarithm of 2. More examples on this kind. We have 25. We know that 25 is 5 raised to 2 x subtracted by 3 raised multiplied by 5 raised to x is equal to 0. And then we have 5 raised to x as common factor. Then we have 5 raised to x minus 3 is equal to 0. The other one is x is equal to 0, as you can see already. Then we have 5 raised to x minus 3 is equal to 0. And then we have adding by 3. Then we have 5 raised to x is equal to 3. Then we have logarithm of x times the logarithm of 5 is equal to logarithm of 3. Then we have x is equal to logarithm of 3 divided by logarithm of 5. B, we have b here. 8 multiplied by 3 raised to 2x subtracted by 3 raised to x is equal to 0. And we have 3 raised to x as a common factor. Then we have 8 times that one. 3 raised to x minus 1 is equal to 0. Then the first one, we have x is equal to 0. It's not much interesting for us. Then we have 8 multiplied by 3 raised to x minus 1 is equal to 0. Adding both sides of the equation by 1, and we have 8 times 3 raised to x is equal to 1. Divided by 8, both sides of the equation, then we have 3 raised to x is equal to 1/8. Or that is 2 raised to negative 3. Okay, I will put it here. 1/8 is the same as 1 divided by 2 raised to 3, and that is what's that? Negative 2 raised to negative 3. So if I will put that 2 raised to negative 3. Now we're ready. X logarithm of 3 is equal to negative 3 logarithm of 2. So our x value is negative 3 logarithm of 2 divided by logarithm of 3, because we divide both sides of the equation by logarithm of 3. Okay. C, we have 2 raised to x subtracted by 2 multiplied by 2 raised to 2x is equal to 0. Then we have 2 raised to x as a common factor. Then we have 1 minus 2 multiplied by 2 raised to x is equal to 0. The first one, 2 raised to x is equal to 0. We have x is equal to 0. Not much interest for us. And we have 1 minus 2 times 2 raised to x is equal to 0. If we add both sides of the equation by 2 times 2 raised to x, 2 times 2 raised to x, then we have 1 is equal to 2 times 2 raised to x. If we divide both sides of the equation by 2, then we have 1/2 is equal to 2 raised to x. If we can change, just change. We have 2 raised to x is equal to 1/2. It's easier for us to see. Then we have x logarithm of 2 is equal to logarithm of 1/2, or 0.5 if you want. Then we have our x now. We have logarithm of 1/2 divided by logarithm of 2. Okay? For C, there is another way of solving that. I think I can put it here. It's not that difficult. Here. I'll put it here. That's it. As you can see here, I have 1/2 is equal to 2 raised to x. But 1/2 is also 2 raised to negative 1 is equal to 2 raised to x. And then we have, as you can see now, we have the same basis. Then we have x is equal to negative 1. If you're going to do this, divided by this, then it is also negative 1. But of course you need to use calculator to do that. But if you don't want to use calculator, then you need to very watch carefully about how to solve them exactly. But if I am your teacher, I should accept this, but maybe not the highest point. Okay. My next video, I will be discussing graphs of logarithmic functions. And I hope you learned something about change of base, and thank you for watching. See you there on my next video.